To understand two-point perspective and its basic principles, we'll start by building a tile floor using a frontal vanishing point perspective. This fundamental exercise serves as an ideal springboard to clearly understand the underlying mechanics of two-point perspective. By mastering this two-vanishing point system, you will be able to effortlessly establish an accurate depth and scale for any figure or object in your drawings. In this video, I deliberately initiate the process with a frontal perspective, as it provides a highly convenient framework from which to derive to a two-point perspective that is much better suited for artistic visualization. Let's begin. The framed area designated on screen represents our active drawing surface. Because several essential construction lines and vanishing points will extend well beyond these borders, it is crucial to keep this in mind and ensure you have ample physical space around your page before you begin drawing. Start by drawing the horizon line, HL, across the upper portion of your page and mark a central vanishing point, VP, directly upon it. Next, draw a parallel horizontal line along the bottom of the page to establish the earth line, EL. Divide this earth line into multiple equal segments across the entire width of the page. Project structural vanishing lines radiating outward from the central vanishing point down to each designated division mark on the earth line. To accurately determine the depth of these tiles, we will employ the classic square method. Draw a horizontal line exactly at the intersection where the diagonal of your initial square crosses the radiating vanishing line, as shown. Next, trace an extended diagonal line running directly through the corners of the resulting rhombus. With this guide in place, you can now project all the remaining horizontal lines across every intersection where a vanishing line meets this main diagonal. To expand the tiled floor further, draw a subsequent diagonal as shown, and project the newly required vanishing lines outward from the main VP. Finally, replicate this exact sequence on the opposite side to complete the grid. Now draw a sweeping arc that spans the open distance between the horizon line and the earth line. This semicircle, highlighted in red, defines our optimal viewing area, the safe zone where you can compose your perspective, drawing entirely free of visual distortion. To demonstrate how we locate our two required vanishing points, I will first construct a basic square in frontal perspective, followed by a smaller concentric inner square, as shown. By extending the lines of the two closest sides of this newly formed inner figure outward, we successfully locate our two primary targets, vanishing point 1, VP1, and vanishing point 2, VP2. Notice that both of these critical points reside completely outside our primary drawing area. We will use the exact span of 4 grid tiles to establish the true scale and length of the cube's closest vertical edge. Draw a vertical line matching this exact measurement to form the leading edge of our upcoming 3-dimensional cube. Next, project a vanishing line from the topmost endpoint of this vertical edge directly toward VP1, and then do the same towards VP2. Now, draw a diagonal line connecting the outer endpoints of both segments, as shown. On the left-hand side, mirror this exact configuration using identical measurements. The precise intersections where these diagonals cross the vanishing lines on either side dictate the exact placement of the cube's remaining visible vertical edges. With these reference points established, draw the lower base lines of the cube. Finally, project your concluding vanishing lines first toward VP1 and then toward VP2 to map out and enclose the upper side of the cube. As you can see, the perfect structural symmetry and balanced proportions of this cube are clearly evident, simply because it is positioned squarely at the center of our drawing space, directly level with the viewer's central line of sight. Let us now examine what happens when an object is shifted into another position. Begin by drawing a reference line here that spans 4 tiles, maintaining consistency with our first cube. Replicate this vertical edge using the exact same measurement, then extend a corresponding horizontal line in the opposite direction. From these points, project the respective vanishing lines outward to both VP1 and VP2. Follow the same diagonal projection method used previously to accurately determine the true depth of this new cube. Construct the corresponding lateral edges and project the next set of vanishing lines accordingly. In this position, you will notice a subtle visual distortion. This occurs naturally because one face of the cube sits significantly closer to the viewer's eye than its contiguous adjacent side. To conclude this exercise, let us look at one final example situated on the opposite side. As you will see, the underlying process remains entirely identical. First, draw a horizontal line to secure your authentic measurement, then construct a vertical edge of equal length and repeat this structural line horizontally in the opposite direction. Next, extend your vanishing lines from these corners back to both vanishing points on the horizon line. By plotting the diagonals, we pinpoint the exact locations for the remaining edges of the cube. Project the final upper vanishing line to firmly establish the top face. Finish the exercise by adding color to each of the cube's visible faces. If you enjoyed this video and found it helpful, please give it a like. If you have any questions or would like me to go into more detail, let me know in the comments. Subscribe to stay updated on my upcoming tutorials and help me create more content. Thanks for watching.